Our session for today in the morning is power supplies, more power, power. Here's a traditional view of an actual power supply. As we see, we have a little on and off button in the back. Usually that's the kill switch, not the one that you would be using in the front of the computer. That's the regular button. That's where you usually plug in the cable. And that's a dip switch that we've spoken of where usually have them auto sensing between the 110 volts and the 220. In this case, it looks like I have a little doohickey that you can push yourself. Our main objectives is to be able to identify characteristics of the power supply and their connectors, sorry about that. Select a power supply based on a given specification. Describe how to remove and install a power supply. And lastly, identify common problems that come up with power supplies and how to address them. So explain to me the function of a power supply as you would to a coworker. Okay, 89% so far participation, not bad. Thank you, Daniel. So yes, basically, as we know, it's the guy that's going to be pumping energy in here. But just so we can think about it in layman's terms or scientific terms, electricity is a flow of negative charge particles called electrons coming in. Then you have your actual voltage. That's the pressure of the amount of electrons that are coming in. If you have your electron itself, which is one little thing, the voltage is the pressure. You can think about as the electron maybe as little particles of water inside a hose, and the voltage, the amount of pressure of water that's coming out. Next is the amount of it is amperes or current. It's the amount of electrons moving on a wire is called a current, and it's measured in amps or amperage. The amount of electrical power is called wattage and is measured in watts. So how do they go with each other? Well, watts is equal to the amount of volts times the amount of amps or current coming in. Questions, doubts? Wires have a resistance, means how much they can actually push to the flow of electrons, and that's measured in ohms. Questions so far or doubts on the electrons, your voltage, your current, your wattage, or your ohms? We understand it? Okay. So AC, that's the alternating current. It oscillates between negative and positive voltage. AC travels on a hot line from the power station itself. Then AC returns to the power station on a neutral line. The neutral line is grounded to prevent uncontrolled electricity in a short. The standard AC here, as we all know, is 110, while in Europe is 220. Direct current travels only in one direction, and it is a type of current that is most used by electronic devices, especially the ones that are using batteries and stuff like a cell phone. Any questions between the AC or your DC? Except for the band, we're not looking for them.
I have a quick question.
Yeah?
I was reading the book on Mike Myers, and I was a little bit confused when he was mentioning that if you, let's say you have a power supply that has a fixed point switch where you can change it from 110 volts to 220
Correct.
volts.
Mm-hmm.
I didn't understand the part where if you change it to European, it doesn't have enough power. I thought more volts, more power, or that just means there's more pressure and it doesn't give enough power.
By definition, is just amount of pressure in the line on the electrons, just as it's the amount of pressure, amount of electrons that are going in there. There's plenty of electricity going in there. But your problem here is you could have all this, but if you don't have enough amps to get your watts, you're not going to get anywhere. Your watts is what you want. Electricity is kind of tricky because yes, we have 110, but your voltage and your amps is what plays in what your actual device can take in. You might notice this in the example of if anybody's tried to connect a printer or a vacuum to your UPS, which is the uninterrupted power supply, or to la regleta, what you call this, the power strip, and then all of a sudden it just how you say pops the little fuse on it and it kills it, because that itself is not able to take that much watt. It can take the electric, it can take the voltage. It's got no problem with the voltage, but the moment you start hitting it with that amount of amp and jalando or pulling that hard from the equipment, it goes down. Doesn't allow you to use that many watts through it. So the electricity is what's coming in from your AC, but when it's coming into your PC or into any other electrical equipment inside your house, a lot of them are not able to take so many watts. It's just an amount of wattage that you can take. So it doesn't matter if you're at 110 or 220. What matters from there is your equipment. I'm not sure if he's saying that for them it's weaker. I can't see how it is, because it's 220. Maybe he wants to put his tongue on it. I'm not sure.
I'm confused because in the book it says that it wouldn't have enough power, so it wouldn't turn
To
up, and
power
then
a
the other one,
PC, to
yeah,
power the PC, if you have a 220, that is correct. If you have a 220 PC and you put in 110 volts, it will not turn on. It will not turn on. If you put a European PC here in the United States, it will not turn on. That is correct. Not enough electricity.
Wait, I'm now more confused.
If you put a 220 computer here in the United States, it will
Not
not
enough
turn on.
power.
It will not turn on because it does not have enough volts, doesn't have enough pressure.
That I get,
If you
but I
put
don't
it the other way
understand.
around, you will blow it up. You got too much.
Yeah, I'm just confused on the book because it was the other way around that I'm thinking. Like, if I put a 110 volt to a 220 volt, I should probably blow up a fuse.
You will blow up the computer if you didn't have what these modern computers have, which I've already seen it happen in the old ones. You will mess up the computer. But nowadays, they have that little dip switch that I showed you in the first slide, that little red dip switch. And usually that will pop to the right voltage if it's the higher voltage. Usually, if it has the auto one. If not, it just doesn't turn on, and you must go to the back of the computer and hit the little dip switch to either 220 or 110 to the right voltage.
Okay,
Just
I think
think about it
I'm
this way.
gonna.
It's like putting your yard hose into a fire hydrant. You can't do it. And vice versa. You can't put the fire hose into your yard. There's no way.
Yeah, I'm just
Although the
confused
holes
because of
fit.
the. Yeah, no, I get it. It's just I'm just confused because how the book describe it. It's kind of the opposite analogy, or maybe I read the book wrong. I'm not sure.
Yeah, I'm not sure. Yeah.
It was
The
very
only thing I'm
weird
aware
when.
of from the old equipment, it doesn't turn, and the new equipment usually it just doesn't let you turn it on. And if you try it with the laptops, I think it burns the little power supply thing. I wouldn't play around with those. You have to be careful when traveling, I assure you. And I know for the PCs for sure, the majority of them have that little red dip switch on the side to avoid that. And it won't turn on. There's no way the computer can turn on if it's not in the right voltage, not in the right uh, pressure. The power supply must have the right voltage. Any other questions? Good questions so far. Thank you. Everyone understands AC and DC, no issues? Continue. All right. Now, why do I have to know all this mumbo jumbo? Well, basically, if we're going to buy a PSU, a power supply unit, we need to be able to do this math eventually. We have to understand what's the load that we're going to be putting in here if we're creating our own so that we can have the proper PSU that we're going to install. Basically, as we stated in a second ago, it converts your AC, your voltage of AC or 220, whichever it is, 120 or 220. And it has a selector switch in the back. Some of them have the automatic switch, as I stated, but the majority of them, the cheaper ones, have a selector switch. The wires in the inside all correspond to different colors, are in reference to your negative or your positive voltage, and it comes in 3 flavors, 3.3, 5, and 12. At that point, everything is in DC. It comes in from AC, converts it into DC. That's his job. Convert everything that's in voltage of AC to DC. And then the overall capacity of this unit of creating everything is measured in watts. So the amount of what he can grab from that 110 to make different types of DC, that amount is measured in watts, which is your volts times amps. Any questions or doubts? For real? So if a client comes up to you and he's very upset, got a brand new PC, he tells you that it only works in Europe. He asks you if there's anything you can do in the United States to make it work.
You would flip the switch in the back.
Only works in Europe. I don't have I bought the cheap model. I don't have the dip switch. What can I do to explain to him the difference between the United States here and or Europe?
That the United States AC comes in somewhere between 110 and 120 volts, and Europe uses 220, 240 volts. So you can't really match it up. You have to switch it.
Yeah. If it's a laptop, not a PC, maybe he can do something. Otherwise, he's got to get some type of converter, or maybe swap out the PSU. If it is a PC, he's gonna have to swap out the PSU to be able to make it work. If he bought a very cheap model, if it's an adapter, some of these companies, maybe he can go into their website and order an adapter that changes. That's a 110 adapter that'll go to the right DC current that he needs to power up that PC. Yeah, we need to be able to explain to them as simple as possible, right? We're not going to get into technical terms and say we see voltage is electrons. No. I don't think he's going to like that conversation. Okay, so inside a power supply, you have, like we said, the main units coming in with 110, 120 usually. You have the converter itself that goes to the DC, and it has the various types of voltage, as we said, depending on the actual part of the motherboard or device that it's powering. It needs to give this connector here, which is the big connector that we saw earlier. That's where you can, the representation of the picture of this humongous connector here, if you guys remember. The one on page 8. We're on page 8 right now. That big connector, that's how they spread out the electricity, starting from 3.35, and then you have the 12. Now, dual voltage option. For those customers that did buy the one that's not very, very cheap and only with one, they have the little dip switch, which allows them to obviously take advantage of both the United States and other countries. A lot of these manufacturers started doing this because they also got sick and tired of the cost to make US PCs or 110 PCs versus 220. Now I just buy one power supply and it's all one computer. Now I can buy in bulk. I get a cheaper rate, and I'm making this exact same computer compatible for both the United States and or any other country. Any questions, doubts? The power switch itself, this is very simple, is that zeros and ones as always. 0, you're off. 1 is an on. It's always cute how they always tend to push things into these things, no matter where you go, right? Obviously, when it's on, it runs in DC to the motherboard, and the power on and off, though, on the front, not to be confused, that's the one to tell it to turn on the physical computer. This here feeds power right into the actual unit. So if I wanted an extra kill switch or something, it doesn't want to turn off, and I really want to, I can always hit this one in the back. That's in the back of the computer. Obviously that's last resort. If it doesn't want to shut down in either which way, even holding the power button in the front, it's another way to do it. Any questions, doubts? All right, our cable and connectors. Woo-hoo. We have our 20 or /24, depending which one you have on your motherboard, called P1. That's power one, the main one. This is the guy that comes into the motherboard and powers everything onto the motherboard itself. Provides, as we stated, the 3.3, the positive and negative 5 volts, and positive and negative 12 volts. Some motherboards require a special 4 or 6 or 8 connector just to power the actual fan that's going to the CPU. Any questions? That's the usual one, and this is the extra pins just for the power, to give enough power for the actual CPU fan. Our Molex. Our Molex connectors basically are the ones here. You have the regular one, and then you have the mini. The 4-pin connector here, those are usually used on the drives, and these here are the floppy drives or other drives that are very small. Haven't seen too many of these small ones anymore. I don't think that many people are using floppy, but this one's still being used on the IDE hard drives. Any questions on the Molex or the Mini? Pretty self-explanatory, I think. SATA and PCIe Express. So, as we heard earlier, we require much more power too to these things. If you'll notice, even now, the actual high-end graphic cards require an dedicated 6 to 8 pin power connector for their resources. It has a CPU usually too, right? Their SATA is an L-shaped little individual here, and it has the support of hot swappable features. That's the great thing about SATAs usually. So, that hot swappable feature. Our pinouts and colors. Page 14 here on the presentation. This is a killer. Those are your colors, and those are your voltage. I've heard of anybody yet tell me that they've had a question on this, but it is for you to know. Why would I need to know this? Anybody want to tell me why I at least need to have a reference to this somehow, that I can come back to this picture at any point to be able to figure out something?
So you can
Make
know
sure
exactly
the
if you're
voltage.
connecting,
Yes,
like how much voltage each thing has.
exactly. To know exactly how much voltage each one has, because if there's something going on and everything was working fine, and I think that there might be a problem with voltage, I should be checking with a reader the voltage of these things, just to make sure nothing went wrong. That would be the case of when I would check. And I need to know which voltage is which. There's 12, 4, so I don't get confused when I see a certain voltage. I don't think it's just low. Not everything is 12. So, anybody want to tell me who's number 1?
It's a Molex 4 or Molex 4-pin connector.
Yeah.
Whatever.
Okay. What is number 2? Somebody else.
PCI.
Okay, PCIe Express. I heard that. Or PCIe. Just used to saying it, the Express. Okay, okay. Number 3.
Aux cable to provide more power.
Such a bad picture. I can't even tell.
It's a 6-pin aux, AUX. I don't know how to pronounce it.
Auxiliary cable. Correct. It's we can see it has 1, 2, 3, 4, 5. It's either 6 or 8. Yeah. That was the one that we said is for what though? The
It's
auxiliary.
provide
Extra
provide
power or
extra.
something like that? They said, right?
Yeah, because it's the older models where you needed that for the motherboard.
That is correct. And so you'll notice that it's smaller than this guy here. 4. What's 4?
ATX.
Number 4?
Mini.
Is that a mini?
Yes,
Mini.
that's the mini. Yeah, these are horrible pictures, but yes, that is a mini. I could tell because of the size and his shape. It's got that weird shape that you would recognize. And that's also the variance between this guy and this guy is that you'll see the size and shape. This one only has 12. I mean, sorry, 8. It comes in either 4, 6, or 8. Number 5. And I alluded to that guy already 5 times.
The P1.
That's correct. That's the P1. And number 6.
SATA.
SATA.
That's a SATA.
There we go. SATA.
SATA.
SATA. Okay. Go on to next slide. I'm going here now to number 16. So, as here, I think this picture looks a little bit better, although it's the same picture, but I can see it better. We had our Molex connector. We have our main power 4 for the PCIe, as we said before. That's the 4 main. Then we have the 6-pin one for the auxiliary power. We have our floppy mini cable. And then we have a 20-pin main power or P1. They come in 20 or 24. And lastly was our SATA cable. Any questions? Next slide, 17. Actually, oh yes, we still have time. Form factor. The form factor determines the size of the power supply and the placement of the screws and holes and slots used to anchor the actual power supply. We have to take this into note whenever we're buying these PSUs. We need to know if we need more power, is it going to fit? Standard ATX, those are the sizes, width, length, and height. Provides a P1 connector along with Molex, SATA, and other required cables. Depending on the ATX model that you buy, some of them come with the fancy, just a whole bunch of holes and a whole bunch of cables that are separate so that you could just plug it in there and it doesn't clog up space and you have that air flow coming in real smooth. You don't waste it with extra cables that are hanging there not being used. The mini ATX and micro ATX obviously are much smaller and designed for that actual space. We always need to take note of what we're purchasing and what the size and dimensions and the wattage, obviously, that we require. Any questions or doubts? Our rails. Generally, power supplies DC current is split into 3 primary DC voltage rails. You got your 12, your 5, and your 3.3. Each rail has a maximum amount of power it can supply. Powerful computers with advanced CPUs and video cards require more power than some rails can actually provide. So then multiple 12V rails with overpower protection allow the balance, the circuitry, and the supply of the power that is required. Most of the PSUs nowadays produce a single and multi-rail PSUs depending on the amount and the type of computer you have. Obviously, the multi ones are for the servers or gaming PCs, and then a regular small normal PC that doesn't require that much will be just 1 rail. Any questions or doubts on
What's
rail?
the color of the 3.3 volt?
The 3.3 was
Is it black?
orange. You got
Okay.
orange, red is 5, and yellow is 12. Purple is 5 standby. I remember that one. And 12 negative is blue. That all depends. Usually 12 is yellow, because you see the positive all over the place, but the negative is blue. So whenever you see a yellow cable inside the computer, throughout the whole computer, that tells you it's a 12 volt. So that's another easy way. So when you have the connector in your hand, when it's coming out of the power supply, if you remember the colors, you'll be able to tell which one's which and what voltage is there. Any other question in reference to the colors and or? If you'll notice, there's only positive 3.3. I've yet to find any negative 3.3. That's the one thing I noticed. There's positive and negative of everything else except 5 and 12, but not 3. Okay. Slide 19, wattage capacity. If you can help me with this slide, Lázaro.
Wattage capacity. A power supply has a wattage rating for total output maximum load, for example, 500 watts, 850 watts, or 1000 watts, and individually wattage rating for each of the voltage output circuits. These wattages capacities are listed in the documentation and on the other side of the power supply. Video cards draw the most in a system from plus 12 volts output.
Thank you. So self-explanatory, as I was saying, most of these PSUs, they have a wattage rating. You gotta be careful with these wattage ratings. Obviously, the ones that you purchase from the manufacturer, when it comes to you, it's got the right watts. Which when we start adding stuff to these computers, if we start having problems, we have to make sure that we have sufficient wattage. Now, if I have 1,000 watts, does that mean that I can always be running at 1,000 watts? I can just put 1,000 watts worth of stuff into this computer?
No, you have to have the right efficiency.
That is correct. You do not want to actually do that. So on the next slide, slide 20, we consider all components inside, including USB, firewall, everything. Now, the rule of thumb here is that they say that to add all the wattage and then 30%. I wouldn't do that. I wouldn't do that. Why? Because that's the minimum. That's the minimum. So I usually tell people, if you're going to go and purchase something, right? This is you purchasing it. Would you buy something that if something happens and you try to add something, now you got to go buy a new PSU? So I would go for 50. The 30 is so you know where you're at, but I would strongly recommend at least 50%, especially if you're going for gaming. Start adding an extra card. You got 2 or 3 cards with all those CPUs. You want enough, because if not, it starts running hot. Just like your car analogy that I told you, just because your car can go 160 miles per hour doesn't mean you're going to step on it and you're going to be going 160 miles per hour the whole time. You have that safe zone, right? That's why they show you how much revolutions per minute your engine's going, and it's going into those sections. But just pretend trying to rev this thing always into that red zone. Not going to work. Not going to help you. Any questions or doubts? And you can pretend that you're in a speed limit, so you can't get past 4th or 3rd gear. You're trying to get to 100 miles per hour in 3rd gear. It just doesn't make sense. It just starts running hot, and you start damaging things. All of these equipments have a wattage rating, so they'll tell you if you purchase a video card or a fancy video card, it'll tell you exactly how much wattage it's going to need. We always goes towards the highest end of whatever rating is telling us. It's telling me between 200 and 300, I'm going for 300. I'm not playing games when it comes with power, because power basically is what everything is running on. We all agree it's all electrical stuff in there. Zeros and ones are being sent by electricity. Next slide. Actually, we are past. We're at 10:20. You guys want to go to your break now?
We only have like 5 slides. We should just finish it.
We might as well just finish it all.
All right.
Yeah, we're pretty close.
All right. So here's the gaming PCs one. As I told you, nice and beautiful. It'll come to you like this, completely with no cables attached. And if you look at it on the sides, it'll have the cables have on both sides connectors, the connectors that go towards the motherboard and the connector that goes to the PSU itself. Continue now to 22. Issuing requiring changes to power supply, obviously building a new system, current power supply failed, upgrades to the system requires additional power. I've stated that before. Considerations, obviously the size of the unit, can it fit? We have to determine the amount of watts that we currently have and need, depending if we're upgrading stuff, type, and the number required of cables and connectors, and our video cards. We need to make sure we have enough for them. Next section here is in reference to removal and installation of a power supply. As in everything, we turn it off, make sure we hit the power, unplug it, hit the power button for about 5, make sure it all discharges, unplug all cables from the motherboard unit itself after we open the case, remove the power supply, look for screws that may be attached to the case only here, not all the screws, but just the screws that pertain to it. Be careful not to remove, obviously, too many of them. To install the new power supply, just do it in inverse. Put in the power supply itself, put the screws back in, plug in all the lines that go towards the motherboard, put your case back on, and then cables, and just power on the unit. So what do you think are symptoms that a power supply issue may have? Anybody want to feedback on that? What are some symptoms it may have?
Go ahead, Pablo.
You go ahead. I was gonna.
I have a real world example one.
Okay.
When you start your computer and it's stuck on BIOS as if it's froze,
Mm-hmm.
it's a sign that the power supply is slowly dying sometimes. In my case, it was.
Yeah, so it's turning on, right? Yeah, power supply
locks up.
dies slowly when you internally the something's happening with its circuitry inside. So it does turn on, gives you the impression everything's beautiful, but it just doesn't work. That's definitely one of them. Any other symptoms?
That there's like not enough watts or like electricity, maybe that doesn't work.
Yeah. So suddenly it just won't either start or it turns off. It's heating up, but all of a sudden it just loses power internally. So what would be the way we can confirm that it is a power supply issue? What can we do?
Multimeter.
Yes, multimeter. That's the reason why we need to know these voltages, because the multimeter is going to be our friend at that point. Now, once again, this is depending on your job and or the situation. Not always we're going to be asked to go and do all these things, but these are things that obviously, depending on the position you have, you should know at least the basics. You're not going to be taking part of power supply, but you may replace one at one given time. Not always, just sometimes, depending on the company and the size. What are the steps you would take to replace the power supply itself? We kind of mentioned it, right?
Yeah, like turn off the power supply, plug the AC cable, unplug the power supply lines to the motherboard,
Mm-hmm.
and remove the power supply.
Mm-hmm.
Essentially the same steps you would take to replace anything in a computer.
Yeah, pretty much. Just we got to isolate the unit at the end. Basically, it's exactly the same steps for all of them. The only thing is the component at the end is what's going to change in the steps for that component. I totally agree. So, slide 25. Power supplies fail in 2 ways: a sudden death or slowly over time, like we had with Lazaro that kind of turned off. With sudden death on a computer won't start, fan in, the power will just not turn at all. Verify, obviously, that the PSU is getting power. Another dangerous thing is some people get confused is it could be that you were messing around with stuff inside, so you might have created a short on the motherboard or on a drive. It happens a lot on the drives with the mini connector for the floppy and or Molex connector. So it won't start because of the short. So you got to be careful where the problem actually is inside the power supply unit, or is it inside the actual PC? One quick way, as we mentioned, was to get the voltage. So what I would do is make sure I turn off the computer, disconnect all the cables inside, right? And then now with my own meter, I plug everything back in, turn on the computer, see if the fan starts now that there's nothing touching. And if it does, I one by one, I start putting it back on to each one to see. Obviously, I'm turning off the computer, putting that cable on, turning on the computer, because none of this stuff is hot swappable, except for SATA. Power supplies obviously die slow when the internal electronics is beginning to fail. So it will slowly, like he said, all of a sudden just turn off and not want to turn, or just get stuck on the post. Here goes our exit ticket. So who wants to read question number 1 for us?
I'll do it. Which of the following is a consideration when purchasing a power supply with the correct wattage? Okay, which of the following is consideration when purchasing a power supply? Let me see. Words.
Yeah, so A, B, or C, or D?
Is it?
I think it's D.
Everyone agree? D?
Yes.
Yeah. So when we're consideration of purchasing one, we want to at least 30% higher, but I strongly recommend getting at least 50%, because the moment that you start adding things to it, then you're again to that point where you're going to be revving the engine too hot. We want to keep it under that. If I buy it with 50%, I got 20% of growth. Do we all agree? All right, cool. But obviously for them, it's 30%. But in the real world, I would strongly recommend 50. It's a little bit more, but it's worth it, because you're not going to fall into that problem again. What features in ATX systems prevent a user from turning off a PC before the operating system has been shut down? So anyone know that one? Justin?
I believe
I'm
it's
sorry.
D.
D?
Soft power.
That is correct. D,
Yeah.
soft power. Yeah, that's the reason why we got to hold it down for almost 5 seconds or 10 seconds sometimes, to force it to shut down. So that soft power shutdown, compared to the button that I said is in the back, right? That's a hard shutdown. That one kills the power. There's no waiting for the hard drive to tell the motherboard that, yeah, I finished doing my job. Go ahead, you can turn off. You hit that switch in the back, it kills everything. Thank you, Justin. Next one. Jordan, number 3.
What type of power connector did a floppy disk typically use? It was mini.
The mini? You said?
Yes.
Sub mini, micro, Molex, a molar?
I believe it's mini.
It's mini.
Should be.
It's mini, I think.
Mini.
If I remember.
Everybody agree, mini? Yep, mini. That is correct. Next question. Number 4, Mohammed. A user attempts to turn a computer and receives no response. The user calls the technician to report the computer is not booting, and a faint smell of something is burning. Which of these following tools will best help identify the issue?
B.
Can we PSU tester, but cable can also be
Okay. Do
burning.
you guys know what's the variance between the cable tester and the PSU tester?
Cable testers are usually to test an actual cable, like usually a what are they called? I don't want to call them Cat5 cables, like Ethernet
Network cable.
cables,
Yeah,
networking cables.
any network cable or phone cable, and some cable testers are for fiber optics and stuff like that. It's mainly to see if the signal is going through. That's all the cable tester will do. A PSU tester will test your PSU, your power supply unit itself, and tell you what's wrong with it. Thank you. Next question. DeAndre, number 5.
Okay. A customer is building a high-end gaming PC and is seeking an appropriate power supply unit. Which of the following feature sets of a power supply should be installed? I'm gonna go with E. No, I'm not gonna go with E. Never mind.
You have to pick 3.
Kind of hard. You gotta pick a whole bunch of it.
I think E's pretty good.
Is C one of them?
Let's think about this logically. They told us it's a high-end gaming PC, okay? So let's look at A. Would I need a mini ITX form factor on a high-end?
No.
You
Okay.
full.
That's like a small computer, right? So that one's
Yeah.
out. High-end number of connectors. Would I need a lot of connectors for a gaming PC?
Yes.
All the controllers I need, yes.
Okay. Would I need a 24-pin main connector or a 20 main pin connector?
I'm pretty sure 24.
24.
It's high end.
I agree. 24.
Right. And lastly, would I need 350 to 450 watts of
No,
power?
I don't think so. I don't think
No.
so.
Too little.
That's just very, very small from what we heard earlier, right? And
Mhm.
lastly is the dual 12-volt rails. Do you think that I need more than one rail of 12 volts for this PC?
Yeah.
Damn right.
Definitely.
All
Damn
right.
right.
So we said yes to B, C, and F, if I heard you guys correctly.
Yeah.
Those would be the
I-
3 that
I
I would.
think-
Indeed, indeed.
Thank you all for participating. There's no questions right now or doubts. This will be ending up the session. Before we go on break, any questions or doubts? No?